Oh, hi, and welcome. Today I'm going to show you how to build something that I should have made years ago. A plasma cutting table that also uses a water tray to catch sparks. What prompted me to make one now? Well, I was tired of supporting steel on bricks and scraps and throwing hot sparks all over myself. And I'm also making a handheld CNC plasma cutter that I needed a good table to use it on. Make sure you subscribe and ring that bell to be notified when I release videos about the handheld CNC plasma cutter. It's going to revolutionize cutting out metal parts for anyone who does fabrication work, and it's portable. See the link down in the description for the videos of the build of that handheld CNC plasma cutter. Back to this plasma table. There are many options for handheld plasma cutter tables, but they are either flimsy or expensive. And few use curved slats or have a water table add-on like this one. So as usual, not being satisfied with what is available, I decided to build my own. Although it's not going to be a huge cost savings over prefabricated tables, it will meet my impossibly high standards and will have a water table for absorbing the sparks, slag, and smoke from plasma cutting. I went through a few design iterations and refined it to be easy to build, few cuts needed, portable, modular, and no weld construction. Now you may be asking yourself, why no weld? If someone has a plasma cutter, they probably have a welder to go along with it because those go hand in hand for fabrication. Well, you may not necessarily have a welder, and this is a no weld design that is very easy to assemble with basic hand and power tools. The frame is all made of 1-inch series 80/20 aluminum extrusion. The lengths I chose use stock lengths that I could find at McMaster and other places too that cut this material to length. This is 2 foot by 3 foot stock lengths. And there are other cut lengths available too. So you could build whatever size table that you want. You could build something like 2 by 4 foot, 3 by 4 foot, 4 by 4, 4 by 6, 4 by 8, etc. The lengths of the extrusion that I received were cut very precisely, and therefore I didn't have to do any trimming to these. I just had to tap them and bolt it together. Hand plasma tables normally have straight slats. I chose to use curved slats because it helps hold the slats in place when the table is lifted for storage, and I'm planning to use it with a handheld CNC plasma cutter that I'm building. Watch this. I mean, I can even flip this thing over, shake it, and the slats do not come out. So that makes it very easy to carry it around and be portable or store it away. Here are all the components laid out. There are 2 3-foot long 1-inch by 2-inch extrusions for the long side rails, and 2 2-foot long 1-inch by 2-inch extrusions for the other side rails, for the shorter side rails. 3 1-inch by 1-inch extrusions will be used to support the slats. So we have one here on each side, and then one in the center, and that's used for the slat support. The slats I'm using here are 1-inch wide by 1/8 inch thick and approximately 2 feet long. I buy these at Home Depot in 6-foot lengths, and they're going to be cut down to 2-foot lengths. These can be cut with a metal cutting bandsaw, or since you already have a plasma cutter, then you can just cut them with your plasma cutter. To hold this frame together, I selected a special type of fastener designed for butt jointing the extrusions called an end fastener. These fasteners are kind of expensive if you buy them from McMaster, but they can be purchased more cheaply from places like eBay, and you can save a lot of money. It's also possible to substitute standard bolts that bolt through on the frames. It's just you can't put as many fasteners in there as you can with the end fasteners. So here we can only put 2 bolts to bolt this together versus the end fasteners you can use 4. End fasteners will be a little bit more sturdy over time. And also these bolts are compressing the whole extrusion piece here, which it's springy in that direction. So it's not ideal, but it works. The side rails could be butted against each other at the corners, and only 2 end fasteners would be needed at each corner, so you'd save on the end fasteners quantity. However, I wanted to utilize the whole 2-foot by 3-foot interior space, so I chose to add an extrusion piece here at the corner where the side rails will bolt onto this extrusion piece. If you were to just butt the material together, you would either lose 2 inches in one direction, or you would have to cut one of these pieces yourself 2 inches longer to make sure you have the full interior size that you want to use. You can cut these legs to whatever length you want. I chose 12 inches from the top of the table because I wanted to keep it portable and fit on top of this water table, and I can also just set it on the ground over something that's not going to catch on fire. Once I can use this table with the handheld CNC plasma cutter to cut out some brackets, that's the first thing I'm going to do is make some brackets for this that allow me to attach folding legs onto the sides. So then it will be ultimately portable and then flat when folded up. To hold the slats in place, I'm using short 1 1/4 inch pre-cut 1/4 threaded rod. So instead of buying a long piece of 1/4 threaded rod and cutting it myself, which you can do too, it was inexpensive to buy them already pre-cut to length. So these sit just a little bit lower than the top of the slats, and they hold the slats in. These pieces of threaded rod screw into a 1/4 T-nut that slides into the extrusion, and you can slide them to whatever location you want to, tighten them up, and then they stay in place. This allows you to make the slat spacing easy to adjust to your desired spacing. In this case, I have the slat spacing at 2 inches. You can make it smaller at 1 inch, but it's going to use twice the amount of slats, which is going to be more expensive. Or you can make it wider at like 3 inches or something like that to use fewer slats if you're cutting out only big pieces on this table. The first step in the construction is to tap the ends of all the side rails with a 1/4 tap. I choose to use a spiral point machine tap because I prefer it over a hand tap because you don't have to back it out all the time. With a spiral point tap, you can just keep moving forward and it shoots the chips forward, especially in aluminum. And just make sure you use some lubrication too with it, that's important. The most important thing is to keep the tap straight relative to the hole as you start. Entering the tap in crooked will cause it to jam and more likely to break the tap. I always recommend using a tap guide of some sort. This drill guide here also works well for keeping the tap straight. Make sure you use tapping lubricant to make it easier to cut the threads. I use a wax-like lubricant in stick form, but for aluminum, WD-40 works well too. If you're careful, you can use a battery-powered drill to power tap, but this is a great way to break your taps, and then all the time savings has been lost. I have a good bit of experience doing this with the drill, and I have broken 1 or 2 taps in the past doing this, but you really have to be just careful. I found this special tap handle that has a 3/8 inch adapter in the back for like a 3/8 inch socket, and I use a 3/8 inch kind of flexible joint socket to allow me to tap these with the drill without putting any undue sideways force on the tap and breaking the tap. So this allows a little bit more leeway when power tapping. After all the side rails have been tapped, tap the ends of these 3 slat supports here. Now it's time to cut the legs to length. I'm cutting 12-inch lengths of 1 by 1 inch extrusion. If you want a table with no legs, then cut the extrusion to 2 inches, and then it's going to be the same height as the side rails. So here, the 3-foot length that has not been tapped is the one that we're going to use for the legs. We're going to have to cut it down to 1 foot lengths, so we'll get 3 legs out of this 3-foot piece. And you can cut it down with whatever tool you have. The end cuts don't need to be accurate or straight. You just need the length, just needs to be correct. I'm going to be using a metal cutting bandsaw. A miter saw with a carbide blade will also cut the aluminum, and a chop saw will cut it. And if you need to cut it by hand with a hacksaw, you can do that too. The legs have to be cross-drilled like this and like that to allow access to the end fasteners. The end of the double width extrusion with the fasteners is going to slide into the legs like that. So we need to be able to access the fasteners to tighten them from the other side of the leg. So what we're going to do is we're going to cross drill some holes that are in line with the fasteners, so then we can pass the Allen wrench through and access the fastener. These holes can just be drilled by hand, they're not precision, we just need to mark the locations of them and drill them. The holes need to be at 0.5 inches and 1.5 inches from the end. Mark these positions and drill the holes. A 1/4 inch drill bit is a good size for this to allow easy access. Cross drill those 2 holes. Now that's going to give us access to these fastener screws on the end. And there you can see the hex is in there. We're going to take this piece that we just drilled here, we're going to turn it 90 degrees, and we're going to cross drill again at the same location. So now the top of the legs is cross-drilled. Now that you've drilled out one leg, it makes it easy to drill out the others because you can use it as a template for the other legs. So you take them like this, stack them inside the vise or some other way to clamp them together. This just works well. Three holes have to be drilled into the bottom slot of the 2-foot-long side rails. These holes are going to be used to access the screws for the slat supports. So we're going to have one support in the center, and then one support is going to be offset by 1 inch from the edge. So we got 1 inch here, 12 inches, and then 1 inch from the end. So there we go, we have our 3 holes drilled, 1 inch from the end, centered at 12 inches, and then 1 inch from the end over here. We do the same thing in the other piece now. We're going to use the first one we drilled as a template for the second one. Just line up the edges, put in the vise, lower it enough so you're grabbing both. Now if I clamp it, then when I move it around, I won't have to readjust the position. And now we have both beams with drilled holes for the slat supports. Now we're going to be adding these slat stops to the slat supports. These slat stops are just 1/4 20 threaded rod, short pieces already cut to length, and a T-nut. So you're going to slide into the extrusion like this. Take the slat supports and starting at 0.5 inches from the end, make marks every 2 inches. There should be 18 marks total. Adjust these dimensions accordingly if you want a closer spacing and more slats. There are two different ways that you can attach the legs to the side rails. And I'm going to show you both of those ways. The first way is that you can use these end fasteners and put them in here like this. They're two pieces. They have a screw and then this sheet metal piece that will slide into the other part. And so you could probably get away with just one of these per side rail, but here I'm using two for additional strength. So then you take your leg and you slide it over top of the sheet metal and the screws get hidden behind there. And then you're going to pass the hex wrench through to reach the screw. Now the other side rail, the long one in this case, I'm going to do the same thing. I'm going to take the screw and the sheet metal piece and thread it into the end here. I'm going to take another one, thread it in here. And as you can see, this method of fastening is quite nice because the fasteners are all hidden. And if you need to slide stuff in the slot, there's nothing blocking the way. And it's very strong because you have two fasteners per side rail. So 4 fasteners are holding on this leg. Another method of attaching the legs on that's quite a bit less expensive and a little bit easier is to use some 1/4-20 bolts with a washer. You pass them through the legs. They have to be long enough to have a substantial amount of thread on their side, in this case about 1/2 inch at least. And we're just going to thread those into the side rails. So one in that direction and one in this direction. Now we can't put 2 in each side rail because this bolt is blocking access to this hole right here, and this bolt is blocking access to this hole here. So we can only use 2, one for each side rail in this case. So it's going to be a little bit less strong than the hidden fasteners. This is what the frame should look like when complete before putting the slats on, minus the rust because I've already been using mine outside. So here are the legs attached, and I've used the hidden fasteners in this case. So you can see the fasteners there on the end. And it's a very sturdy frame before you even add the slats. I hope you found this video helpful and you're going to go and build your own awesome plasma cutting table. And definitely I would add on this water table at the bottom. I mean, it helps contain all the sparks and everything, and it reduces the amount of smoke. And if you're interested in seeing the build of the handheld CNC plasma cutter that I'm making, make sure that you subscribe so you'll be notified when those videos are released. I'm really excited about that. I mean, it's going to be so cool to be able to precision cut thin or thick sheets of metal to be able to do fabrication with using only a handheld device without having to have like a whole CNC gantry. It's really going to revolutionize my workflow and how I think about making things when I'm designing with the ability to use that kind of tool. There wasn't enough time left in this video to include the details about the water table. So watch the next video in this series to learn about which model and size I used, where you can buy it, and how to select the right one at the store.